Welcome back all, this is Daz from LocoNet Techniques. So up this week we're going to look at the new holdings for ARCOMORA, which is Arduino controlled motor railroad out of the Netherlands. So we've got the new, and this is actually not out as of yet, this is the new LocoNext, which is the LocoNet device, which coupled with its little offsider here, the Oki 4x4, which gives you 16 occupancy detection sections and another 4 which you can use either as an input or an output. During the week when I was recording this video, I ticked over 5,000 subscribers, so thank you for everyone for supporting my channel. So without further ado, let's get started. So what's new about these new little guys? So I'll just read off here. So now, before I think you could only go up to like 256 addresses. So you're thinking, well, I'm not going to need any more than 256 addresses, but they now go up to 4,096. So where I can see that very handy. So on my layout, I've got individual sections and they've got blocks of addresses. So it just gives me plenty of leeway. I know that my Alpine section is address 1,000 and onwards, and I look at doing it that way, where it's got 4 extended ports, these 2 little blue ones, so they can be used for as an input or an output. Also with this little guy, and I'll explain how this is all done, via this little switch here, and also running some 12 volt DC to the board. It can be used as a standalone LocoNet buffer, which is really, I think, would really be really handy for someone that might want to get into the LocoNet communication side of things, but their current DCC station does not have LocoNet, so you can actually use one of these. And also, if you're into Arduino, this is still Arduino based. Obviously the chipset is Arduino. Obviously it's still Arduino driven, but now you don't have to go for the old section like this where you had to work out what type of Arduino you needed to get and then solder up the little board which clips on the top. At the time of recording, still really cheap for the little kit. So for just the Arduino, sorry, the LocoNext, you're looking at about 20 Australian dollars. So really good value for money considering what other brands are charging you out there. So what we've got here is the basic connections. So over at the top left here, we've got the LocoNet that's coming in from the command station, in my case the test rig DR5000. Here we got the little USB interface that goes to the computer. That's how we program it, and I'll come over to that screen in a second, show you how that all that works. So here we've got the new ARCOMORA LocoNext LocoNet interface. Currently it doesn't have the lid on it. Lid goes on like that. It does have a sticker like that, but I've yet to put that on. So with this side we've got the new OkiNext 4x4, and I'll go through that very shortly on how you set up the cabling to get your different groups. So coming in the top here, we've got from the command station the track output. So that's what I'm going to be using, the common, and then you've got all the track outputs, all 16 of them. So I've just got playing around with 3 at this point in time, and just to show you how it works. And at this point in time, don't worry about these connections down here. We'll talk about more when we look at the standalone LocoNet option. PCBWay offers a variety of services ranging from PCB production and assembly to 3D printing, CNC machining, sheet fabrication and injection molding in a variety of materials. If you do not have the correct tools for the job, you can quickly upload your Gerber file for a PCB and press enter and get a quote in no time at all. This makes PCBWay a good option for your projects. Alright, so what I've got here is what they call the putty. Now I'll link to a video that I've done previously on this, how you actually download this and get into this, but this is pretty well it's how ARCOMORA gets you to justify all the settings within the LocoNext. So the first thing we need to look at is entering a value between 1 and 100. So what this is doing here is it's just an administrative number, so it doesn't really take much effect. So we're just going to go number 1, obviously, then you do number 2, 3, 4, and it just shows up that way. So now the next one we can do is set your base address. So The beauty of this system here is we can go out to over 4,000 LocoNet addresses. So you're thinking, oh, you're never going to have one with 4,000 addresses. Now, what I've done on my layout is what you can actually do is have sections have a range, or physical sections or areas within a layer have a range of addresses. That they might start at 100, they might start at 1,000. It's just up to you what you want to do. So we're just going to set this at address number 1. So then it's going to give you the base address, and then all addresses after that, the 16 plus the 4 extras, are going to be +1. So do we want to set inversion? No, we don't want inversion. So what we mean by inversion is, so the default port inversion by default is low, which is 0 volts. And at this point, the signal is seen to be busy. However, if a light barrier or IR is used, you want to flip that up. And when the light beam is interrupted by a locomotive, wagon, or whatever, it brings up to 5 volts. So by using inversion mode, LocoNext will see a high signal as occupied. So it just toggles it that way. So specify delay before setting occupied. So we can actually set in a little delay. So how that can be handy is if you start getting a few little false occupancies here and there, you can have a delay of say half a second or a second, just so it takes a second before it actually fires off and then goes off to your software of choice, train controller, JMRO, or the like. So 1,000 is one second, so let's just leave that at 100 milliseconds. And also on the flip side, when you've got up to 3 seconds for when you want specifying a delay for when it's setting it free. So we'll just do 100 as well. So at this point, what you can see all the ports have been set. Ports 1 through to 16 have all been set to active. They're not inverted, and it gives us our addresses. And then we've got the extended ports, so the top 16 ports are all coming out of the Occy 4x4, but the extended ports 17 through 20 we actually access via the LocoNext module itself. So if that's all we want to do at that point in time, that's fine. But what we can actually do is we can go question mark, and it gives us a whole lot of other options that we can go into. So the sort of options we can set the base address. So this is when we can actually add a little bit more to this. So we can go into individual port settings. Let's just go look at that very quickly. So then you're selecting ports between 1 and 20. So let's just look at the first one. So then it gives us some more options. So we can set a LocoNet address. So what we can actually do, we can go into individual ports, and we can go outside of that naming that numbering convention that we said the base address was. So we might want to have, let's say, port number 10 on address 20. 25 or something similar. And then we just go and do that. You can set inversions, and you can actually turn ports on and off. So this is active and inactive. So if you're happy with all that, you just push an enter, and then it's going to come back to that main screen. So what we can do, we can go into a debug mode, and I'll show you what that might just look very, very quickly. So debug mode is on. So we then push E, which gets out of it. And I'll just show what that looks like. So basically what I'm doing here is just putting the DCC plus, and as you can see, it just goes through. It just gives you a lot more information of what the actual port is doing at that particular time. So if I've now taken it off, it is now inactive. It'll say that it's actually free. So if we want to go back to C, that goes to the beginning, gives you the specific options that we want. And we'll go to debug mode, and we'll turn it off because that gives you way too much information when you're just testing. We can reset from this point in time. So if you just get yourself all muddled up, you can actually hard reset the whole thing and go and start again. Now the biggest thing is just make sure whatever you do, so it takes the program, you don't just go and X out of this or shut the putty down, so to speak. What you need to do is make sure you do the exit to normal mode. So normal mode is when it starts detecting. So that's the same for if you're looking some of the DCC Next items that he's got as well, the stationary decoders that I'll do in subsequent videos. But you got to make sure that you exit into normal mode, else the programming that you've just done won't take. So let's go E. All right, and then it comes back. So what's really cool from here, what I normally do is, just so I know what's on each module, I'll just take a snipping of that, and then I save that snipping. Then I'll just save that snipping for my own records, so then I don't have to keep writing all this stuff out. So it's going to have the base address at the top, so you just put number 1 on it, and then module number 1 is going to be that address range. Okay, so what we got here, we've got the rig set up as we just explained. Now, what we're going to look at doing is testing these 3 outputs. So they're just simply addresses 1, 2, and 3, the LocoNet addresses, that is. So coming up on screen now, on the left-hand side here, we've got train controller very basically with blocks 1, 2, and 3 set at addresses 1, 2, and 3 also. And then we've got what they call the putty interface that talks to the LocoNet Next. So what we're going to do, we're just going to purely go across, and we're going to go to number 1. And you're going to see a few things. You're going to see block number 1 activate. And then you're going to see port 1 with address 1 go occupied, then free. Let's just show you that again. Now we're occupied, the block goes red, so that denotes that something's there. So we'll just show you on block number 2, same sort of thing, goes as occupied, you take it off, and the block should go free shortly. Bit of a lag there for some reason, I have to go and look at the settings. Same here, we've got the block 3 going occupied with address number 3, block number 3 on train controller also, and then it'll turn itself off. That's basically how the occupancy detection works. So just to give you some sort of idea, so I should have gone through it, also attached to what they call the DCC1, which is just a 10 ohm resistor. So that just emulates just either some lighting or a locomotive that's coming into an occupied, or electrically isolated block on your model railway. So one of the other features of the ARCOMORA LocoNext is that can be a standalone LocoNet. So what does that mean? So basically what it means is it's its own LocoNet hub. So if you've got a DCC command station that does not have, say, a LocoNet communication bus like the DR5000 or the Z21 I use on my layout, but you've got DCC track power, which is all good, but you want to start getting into JMRI, train controller, or programs like that. So what you can actually do is use this system in a standalone mode. So before, this little switch just here was across to the right. We then flick it across to the left. Down the bottom here, we feed the board with a 12 volt DC, so just be very mindful it is polarity sensitive, so just make sure you get them around the right way. So 12 volt DC. The rest of the connections upstream from that into the Oki are exactly the same as before. Now I'm not going to go through the testing of it again. You get the idea of what it actually does. What we can do, we can go standalone mode. So you don't have to do anything more to the putty here. Now this is obviously train controller, and as I said, it's interesting keeping this nice and short. All you would do is we add another digital command station, so it's very similar to train controller, so which we've done there. Then we go into serial mode, and then I'm pretty sure this is on COM port 7. So you just select COM port 7, it connects like it did before, and then when you go and test each one of these, so these little guys will light up just as they did before to show there's a track that's occupied. So what we're currently looking at here is the Oki. So we'll just quickly zoom in on that. So I thought it was quite relevant to talk about how it's come its name, the Oki 4x4. So it's got 4 groups, as you can see there, group A, B, C, and D. So underneath there you've got JP2, JP1. So these refer to the dip switches, which are indicated in yellow. So what that effectively does is you can now have the whole Oki board that's connected up to, say, 1 power district for your circuit breakers, or you can actually break it down into 4 separate groups that can have a different power district into each, which gives it great flexibility. And obviously you can also have the flexibility of having 4, 8, 12, and then
16, all electrically isolated.
So that's the end of the video. So like always, I have 3 questions. So question number 1, have you used ARCOMORA products before, or what are you using for your LocoNet, either LocoNet Buffer or standalone LocoNet occupancy detection? Number 2, if you are using ARCOMORA, how are you using it? What programs are you using? I'm a train controller user. So are you into JMRI or Rockrail or iTrain or something similar to that? And number 3, if there's any glaring errors, please reach out to me and I'll try to right my wrong in subsequent videos. Also, I'd like to, if anyone consider to become either to buy me a coffee or a Patreon. So every little bit counts. So thank you very much for all the people out there that have donated to the channel. It helps me pay for subscriptions and the like to keep the content rolling. So thanks for watching and I'll see you next time.
Make sure you subscribe, click that little bell icon to be notified of upcoming videos. Support us on Patreon, like us on Facebook and Instagram at Model Railroad Technique.